All right, 7.3, we're going to use functions involving e. And e is just one of those special numbers in math. You can actually buy like a 180-page book about the number e. So it's just one of those special numbers. And you can find it in your calculator. So go ahead and look on your calculator. Okay, so go ahead and get out your calculator and look for the e button. It's probably e to the x. And it's probably right above your ln button. So look for ln, and then you might have to do second ln, and then that brings up your e button. If you have a backwards calculator, like if you were doing like e to the third power, if you have a backwards calculator, you'd put in 3 first and then do the second ln, but we can talk more about that later. All right, so just involving e, so we're gonna be we're going to do growth and decay again, but now with the natural base e. So our bases for decay and growth were things like 2 to the x, so the base would be 2, or 3/4 if it was a decay function. So now e is going to be our base. Okay. All right, so here's basically what you need to know from here. It's the natural base, it's irrational. And as n approaches positive infinity, e approaches this. So we have e to the first. So if you go ahead and put e to the first in your calculator, you should get 2.718 if you round. Right? So the limit thing you will discuss in probably honors pre-calc and calculus, so don't worry about that, but make sure you can get this on your calculator, because we're going to use that a lot to graph these functions. But it is a base, so we have bases and exponents for example 1. So what we're going to do is just simplify. So right now the bases are being multiplied, which means we're going to add the exponents, and so we just get e to the 7th for part B, or for part A. For part B, go ahead and see if you can do that all by your lonesome. Pause. Right, so we can, 12 divided by 3 is 4, and then we can subtract the exponents, and so this is going to be 4e to the first. Okay. For C, go ahead and do that one all by your lonesome, so pause the video, and then hopefully you distribute that exponent, so you get 5 squared times e to the negative 6x. Right. So if you got that part, great. And then this is going to be 25 times e to the negative 6x. And then that has the e part has a negative exponent. So we are going to bring this downstairs. So our final answer is going to be 25 over e to the positive 6x. So if you got all the way down there, all by your lonesome, awesome job. Right? A little calculator fun, so e to the 4th, right? So e to the 4th, you should get 54.598, so try that. You'll probably look for, again, the second ln button, right? And then you'll have, once you do that, the process of doing that is your e to the x, and then after that put 4 and then equals or enter. If you have one of those backwards calculators, you're going to do 4 first, then second ln, and then equals. So either one. And then go ahead and find this one in your calculator. So e to the negative 0.09, because we need to know both of those. So pause the video and get this. Pause it. Okay. All right, and then for guided practice, we have 1, 2, 3, and 4 are similar to example 1, and then 5 is just like what we did. Right? And if you want to turn 3/4 into a decimal, you can. All right, our next slide, which you must write down, please pause this, write this down. right? This is what we're going to spend the most of the time on, is graphing these functions. So the big idea is we have exponential growth and decay with the same thing. So the big idea here is if the exponent, if r, so we're discussing this part right here. So if r is positive, so for example, if we have e to the positive 3x, that would be a growth function. Or e to, even if it's 1/2 x, that's still positive. So as long as r is positive, these are all growth functions. It could also be e to the 0.2x. So we're not worried less than 1, greater than 1. All we care about is if the exponent is positive. So if the exponent is positive, then we have a growth function. Okay, so, and then what we're going to do is we plug in, we make a little t-chart. We plug in 0, so the most basic one is e to the x. So when we plug in 0, anything to the 0 power is still 1. So that's why they get 0, 1. And then we plug in 1, when we put that on our calculator, we get about 2.718. And that's where that comes from. And then it's a growth function. So it starts really, really close to 0 and goes all the way up. Okay. And then the domain for this one, domain is going to be all real numbers. So that doesn't change. And then range is going to be y is greater than k. Since k, there is no k, it's greater than 0. So before we move on to decay, pause this, write this all down so you do not get homework club tomorrow. You don't want to be in the club. Okay, exponential decay, a little different. So things like e to the negative 3x is an exponential decay. E to the negative 0.5x is exponential decay. E to the negative 10x is also exponential decay. So the moral of the story here is if the exponent is negative, then it is decay. It's a decay function, just like you learned about yesterday. Right. And then how you graph that is the same idea. You make a t-chart. You plug in 0, you plug in 1, right? So if this is e to the negative x, then we have e to the negative times 0. Well, negative 1 times 0 is just 0. So anything to the 0 power is 1. And then we have e to the negative 1, which is going, if you put that on your calculator, you'll get 0.368. And then it's growing very, very, it's starting high, and then it's decaying all the way down to 0. So please don't stop here. If you stop there, it's not technically right. So make sure you get super, super close to the asymptote. And then for this one, our domain is still all real numbers. That does not change. And range is going to be y is greater than whatever k is. We don't have a k right now, so it's going to be greater than 0. Okay, so take a minute, write that down, pause if you need to. If you have any more questions, then pause, write your question down, and ask me in class tomorrow. Okay, for this guy, so now we have h and k, all right? So again, write this down, please. H is horizontal shift. Our friends are consistent. H is horizontal, and it is the opposite. K is the vertical shift, and that is the same direction. So they haven't changed, they won't change, right? So step 1 to graph would be to graph a times e to the rx. So we're just graphing this part. Same as square roots, cube roots, and the growth and decay that we just did in this chapter. All right, and then if you can use 0 and 1. If you forget what a decay or growth function looks like, then please use more of them. You can use negative numbers, like -1, 2, 3. Domain is all real numbers, so you can plug in whatever you want for x, but 0 and 1 for x are the main ones. And then for step 2, again, our asymptote, our boundary line, our magnetic force field is going to be y equals k. So if there's no k, then y would be equal to 0. And then we shift it. So we take each point and we shift h and k, whatever those numbers are. And then for step 3, our domain is going to be all real numbers, and our range is going to be y is greater than k. So questions, concerns, write them down. But please make sure you write this down so you don't get a homework club. All right, so let's start graphing them. So look at A and look at B and put growth function if it's a growth function, and put decay if it's a decay function. So step back, look at your exponents. Which one is a decay function? So if you put decay for B, you are correct because the exponent is a -0.75, so that is definitely going to be a decay function. All right, for A, it's a growth function because we have a positive 0.25. So if you got that right all by your lonesome, great job. Right. The next step we want to do is for part A, we will get some points on the board. And there's no h and k, so we're going to just graph the whole thing. So y equals 3 times e to the 0.25x. Okay, our basic ones that we want to use are 0 and 1. So and if you can get 0 and 1 all by your lonesome, please do that now. Right now. Go ahead, pause the video and see if you can work that out all by yourself. Okay. So we have 3 times e to the 0.25 times 0, which is the same thing as 3 times e to the 0 power. Right? Order of operations, same as chapter 7.1 and 7.2. So we do the exponent first, that turns into a 1, and 3 times 1 is 3. The next one, we have 3 times e to the 0.25 times 1, which is 3 times, and then e to the 0.25 is 1.284. And so if you round, you get about 3.85. Okay. All right, so if you didn't get these, then please go back and just listen to the explanation. If you did those all by your lonesome, that is great. You are well on your way to understanding this section. All right, so when we graph these, we have 0, 3, so right about there, 1, 3.85, so a little bit less than 4. Again, if you're not sure how the graph goes, then you might need to graph more of them. Our asymptote is at y equals 0. Okay. There's no k, k is equal to 0. And then if you graphed this, or if I graph that, can you explain what's wrong with that graph? It's not complete. So take a minute, think about it. What is wrong with that picture? Okay. Now, if you said to continue the graph like that, you would be correct. So make sure you continue the graph, drawing arrows at both ends of the graph since they go on, and then we write our domain and range. So domain is going to be all real numbers. Range, write the range all by yourself. What could the range be? So if you have y is greater than 0, great job. Right, and part B is done. Or excuse me, part A is done. For part B, we're going to do the same idea. Um, but we have H and K, so we're gonna shift it. Okay, I made some room, so we have plenty of room to work, but we are going to graph this first. We're gonna graph just this part, and then we're gonna shift. So I'm gonna add one more number just for fun. So we have 0 and 1, those are our main ones, and -2. Okay. So go ahead and find those y values just for the ones that I boxed. So we're just finding y values for e to the -0.75x. So pause it, do that all by your lonesome, and then we'll talk later. Go ahead and pause it. You can do this. So for this one, we have e to the -0.75 times 0. Well, that -7.5 times 0 is 0, so we have e to the 0, which is just 1. And then we have e to the -0.75 times 1. So that would be e to the -0.75. When you put that in your calculator, you get 0.4724. And we have, when I plug in -2, -0.75 times -2, that turns into a positive 1.5. When you put that in your calculator, you get about 4.48. So if you got those numbers, plugged in 0, you got 1, plugged in 1, you got 0.4724, and you plugged in -2 and you got 4.48, great job. Right, if not, rewind and then check out what I did. All right, so when I graph 0, 1, that's right about there. 1 is it's about half, so in between 0 and 1, and -2 is about 4.5. 1, 2, 3, 4, 4.5. So I wanted to graph that so you know it's definitely a decay function. So it looks like this. All right, so when we follow that, we have this. Okay, and we're done. No, just kidding, we're not done. You said, what about H and K? You are following along. So H, let's see, what is H? That's the best friend, so that would be in the exponent with the x, and it's opposite, so what is H? Write it down. Hopefully you wrote down 2, and then what is K? What is K? And hopefully it's same, you keep it the same, so it's positive 1. Okay, which means this is going to change our asymptote, our boundary line. This is our asymptote, and so that's going to be at y equals 1. All right, so here's our new boundary line, and then we're going to shift. So we're going to shift each of the points. So this point I'm going to go over 2 in the positive direction, 1, 2, and then up 1. We're going to go over 2 and up 1. Over 2 and up 1. All right, so those are our brand new points, and then here's our brand new line. And if you graphed that, would be technically not correct yet. So what do I have to do? And if you said continue the line and draw arrows on both ends, you are right. Okay, we got to show that that line gets super close to our asymptote. It gives it a big hug. And then what is left to do? Okay, you said domain and range, you are correct. So domain is all real numbers. Range is going to be greater than k, and k was equal to 1. Now we are officially done. All right. Again, if you have any questions, write them down and ask me tomorrow. Okay, and here's guided practice. You can totally do all of these. Decide right now, though, is number 6 a growth or a decay function? Same with number 7 and same with number 8. Right. And then we're going to skip number 9 for the guided practice. And then now we have continuously compounded interest. This is what most people use. Instead of compounding it quarterly or daily or monthly, now it's compounded continuously, which is where E comes into play. So P is the principal. Again, write this down so you get full credit tomorrow. R is the rate, and T is time. So it's a lot simpler than our other version. Write that down. All right, so for example 5, it's compounded continuously. So as soon as you know continuously, you're thinking, oh, that's PERT. So A equals P times E to the RT power. Right? If you take any business classes in college, you will be talking about this in your business calculus class. All right, so figure out what P is, figure out what R is, and figure out what T is, all by your lonesome. What is P? What is R? What is T? Pause it, write them down. Okay. So principal would be 4,000, right? A rate is going to be 6%, and hopefully you get bonus points if you change it to a 0.06 already. And then time is 1 year. All right. So if you did all that by your lonesome, great job. And now we're going to put in our formula. So we have 4,000 times e to the 0.06 times 1. Okay. And then with order of operations, you're going to do this part first. Right? And then whatever you get, you're going to multiply that by 4,000. And so you should get, when it's all said and done, you should get a $4,247.35. And then for example 10, you can totally do that. Instead of 1 year, now we've got 2 years, 5 years, and 7.5 years. And the principal and the rate has changed. And then 11, finding the amount of interest. So let's go back to example 5. To find the amount of interest, we're going to just take the money we have, subtract 4,000. So our interest that we earned was $247.35. Okay, and this one's a little shorter, so I will see you in class tomorrow.